Good morning, students. This is your live class for science, chapter number 13, magnetic effects of electric current. Please join this class. Chapter 13, magnetic effects of electric current. You have already studied about electricity, in which you studied about current. You know what is current, what is potential difference, what is resistance. You are familiar with that. You know the difference between charge and current. You know the difference between potential and potential difference. All of that you have studied in chapter electricity. Now, what is this chapter? This chapter says magnetic effects of electric current. Okay, so what does it mean? What is the meaning of this topic of the chapter? That electric current has magnetic effect. As the name suggests, आपको चैप्टर के नाम से ही क्लियर हो रहा है that electric current has some magnetic effect. Okay, what is current? Moving charge. Okay, what is magnetic effect? What is magnet? You know about the magnet. Magnet is a piece that attracts iron or other metals. Okay, so magnet attracts iron. You know about the magnet. Magnetic effect or magnetic field. What is magnetic field? Magnetic field. What is magnetic field? Magnetic field is an area. Okay, for example, आपने फायर कहीं पर आप फायर लगाते हो, आग लगाते हो, उसमें चारों तरफ जो है हीट होती है. ओके, so that is the area of the heat. Similarly, magnetic field is an area. For example, this is a magnet. Okay, magnetic field is an area around magnet at which it exerts its force. Okay, magnet के अराउंड जो एरिया है जहां पर मैग्नेट का फोर्स है. फॉर एग्जांपल, मैग्नेट अट्रैक्ट्स आयरन. इफ यू प्लेस आयरन हियर, इट विल नॉट अट्रैक्ट बिकॉज़ मैग्नेटिक फील्ड नहीं है. जैसे ही आयरन मैग्नेटिक फील्ड में एंटर करेगा, इट विल स्टार्ट अट्रैक्टिंग. सो इट मींस दैट मैग्नेटिक फील्ड इज एन एरिया अराउंड मैग्नेट. ठीक है, into which the magnet can exert its force. Okay, मैग्नेट के अराउंड जितने भी एरिया में मैग्नेट का फोर्स है, दैट इज मैग्नेटिक फील्ड. ओके, वो मैग्नेट का फील्ड होगा. You know that magnet has two poles. आपने previous classes में smaller class में पढ़ा है. Magnet has two poles, north pole and south pole. Right? A bar magnet जो होती है, it has two poles, north and south pole, and you also know that north pole attracts south pole. Means unlike attract each other and like repel each other. So these two magnets will obviously repel each other because they are same poles, and if like poles attract each other, so in this case these two poles will attract each other, right? Because unlike poles attract each other. This is very basic, आपको ये पहले से पता है. Now there is a device which is used to detect or know the direction of north and which is the direction. There is a device which is called compass. What is a compass? If anyone knows, please answer. What is a compass? Compass is a device that is used to know the direction. Okay, as you know, compass is a device and it has a bar magnet. इसके अंदर एक bar magnet होती है. Inside compass there is a bar magnet. Okay, and this bar magnet always points in north south direction. You also know that compass always points towards north and south direction. Why does this happen? Why does compass show north and south direction? As you know, that our Earth has two kind of poles, magnetic poles and geographical poles. Okay, this is your Earth. There is a geographic pole, North Pole and South. Okay. Also, there is another kind of pole which is called magnetic pole, and magnetic pole is very near to geographic pole. So you can say this is the geographic. This is geographic pole, geographic, and this is magnetic. Okay, magnetic pole and geographic pole. So there is a difference between these two poles, that geographic north pole is close to magnetic south pole. Do you understand that जहां पर geographic north pole होगा वहां पर magnetic south pole होगा, जहां पर geographic south pole होगा उधर magnetic north pole. Okay, so now the question is, why compass shows direction in north and south direction? So the answer is that you know that magnet attracts another magnet, which means Earth. Okay, Earth is also a magnet, so it has magnetic poles. So this north pole of compass, the north pole of compass attracts the south pole of Earth, magnetic south pole of Earth. So this north pole will point towards the magnetic south pole, and this south pole will point towards the magnetic north pole. Right? North pole of compass points towards the south pole of magnetic. Okay, and south pole towards the north magnetic pole. But actually, as you know, the magnetic south pole is geographical north direction. जहाँ पर magnetic south pole है वो actually north pole है of Earth. So that's why that is north direction. So that's why compass always points towards geographic north and geographic south. Geographic से मतलब है हमारा direction. Okay. Geographical north south means north south direction. Magnetic north south is magnetic poles. So north pole of compass points towards the south pole, south magnetic pole, which is actually north of north direction. So that's why compass always points towards north and south direction. If you have any doubt, you can ask. So, magnetic effects of electric current. Any current carrying conductor. Current carrying conductor. It might be straight, it might be circular, or it might have many turns. Any kind of conductor, current carrying conductor, has magnetic field. It means that this will behave like a magnet and it will attract metals, iron towards it. Okay, attract or repel. Okay, so this is straight conductor, this is circular, and this is multiple coils. So all kinds of current carrying conductor show some kind of magnetic behavior. But I am asking one question. There is a charge, positive charge. There is a positive charge. Does it have any magnetic field? Yes or no? Please write down that if there is a positive or negative charge, will it have a magnetic field or not? Obviously not, because magnetic field होता है सिर्फ करंट का, ना कि चार्ज का. और चार्ज और करंट में डिफरेंस होता है. What is the difference between charge and current? Charge is stable, but current is moving. Current is moving charge. This is current. Okay, इसका magnetic field होगा. जो चार्ज एक प्लेस पर रखा हुआ है, मूव नहीं कर रहा है, उसका magnetic field नहीं होगा, because only current has magnetic field, only moving charge has magnetic field. So let's start this main concepts of this chapter. Electric current has magnetic field. So how it was discovered that current has magnetic field? What happened? There is a, you know that this is a circuit. सर्किट में बैटरी होती है, की होता है, और भी डिवाइसेस होते हैं, मीटर वोल्टमीटर आप लगा सकते हो. You should know that this terminal is positive. बैटरी की डायरेक्शन आप सबको पता है. जो लॉन्ग लाइन होती है that is positive, जो शॉर्ट लाइन होती है that is negative. So positive and negative. The direction of current is always from positive terminal to negative terminal, right? You know the direction of current is positive to negative. So इसमें direction क्या होगा? Positive to negative like this. So can you tell me this is clockwise or anti-clockwise? ये जो current की direction है, एक clock जो clock होती है, उसमें जैसे मिनट या सेकंड की जो नीडल होती है वो कैसे मूव करती है? ऐसे, राइट? इट मूव्स लाइक दिस. पहले 12 फिर 1 फिर 2 फिर 3 फिर 4. इट मूव्स लाइक दिस. सो दिस इज क्लॉकवाइज. सो इस फिगर में बताइए ये जो डायरेक्शन है ये क्लॉकवाइज है या फिर एंटी क्लॉकवाइज है? कैन एनीवन राइट? ऑब्वियसली दिस इज क्लॉकवाइज क्योंकि डायरेक्शन कैसी हो रही है? Like this. This is clockwise. Okay. So this is clockwise direction. What is anti-clockwise? How can you make this anti-clockwise? Anti-clockwise करने के लिए आपको क्या करना पड़ेगा? बैटरी के टर्मिनल्स भी चेंज करने पड़ेंगे. So change the terminals of the battery like this. Now this is negative terminal and that is positive terminal. Okay. I will draw this figure. This is your battery. This is negative, this is positive. Okay. Now the direction of current is from positive to negative terminal, which means the direction of current is like this. Now this is clockwise or anti-clockwise? See, the direction is from here to here. This is like this. Obviously this is anti-clockwise. So clock जो move करती है उसके opposite direction as. So this is anti-clockwise. Okay. So how it was discovered that current has magnetic field? So you know that magnet attracts another magnet, attracts or repels. Magnet के around अगर आप कोई magnet रखोगे या कोई magnet का metal का piece रखोगे, then it will either attract or repel. Okay. So what happened? This is an electric circuit, electric wire. When we place a compass needle, जब हमने compass needle यानी एक बार मैग्नेट को इलेक्ट्रिक वायर के पास रखा, what happened? This compass needle shows deflection. Deflection means it displaces from its position. It means that there is some force on this bar magnet. Okay, and it can only happen. किसी भी मैग्नेट पर फोर्स कब लगता है? जब उसके पास कोई और मैग्नेट पास साथ में रखी हुई. So it means that this electric circuit also has magnetic field. That's why compass needle shows deflection. Bar magnet shows deflection because this exerts a force on magnet. So that's how it was discovered that electric current has magnetic effect. Oersted was a scientist who discovered this concept that every current carrying conductor has a magnetic field associated with it. Okay. If you have any doubt, you can write in comments. So we are talking about magnetic effect. So let's first study about a magnet. You know that a bar magnet has two poles, north and south. You also know that every magnet has a magnetic field. Okay. Now, magnetic field is a quantity which has both magnitude and direction. Magnetic field की एक value भी होती है और एक direction भी होता है. Okay. If I ask you, जो एक बार मैग्नेट है, इसका मैग्नेटिक फील्ड है, राइट? What will be the direction of this magnetic field? इसकी डायरेक्शन क्या होगी? मैग्नेटिक फील्ड. देखिए ये एरिया है जहां पर इसका फील्ड है पूरा, यहाँ पर इसका मैग्नेटिक फील्ड है, एरिया इन विच इट इज exerting its force. Okay, so this is magnetic field, but will be the direction. What will be its direction? So how do you know? What you have to do, you have to take a bar magnet. आपको एक बार मैग्नेट लेनी है with two poles north and south. उसके अराउंड आपको आयरन के पीसेस, आयरन के छोटे छोटे पीसेस ऐसे डिस्पर्स करने हैं. ठीक है, बार मैग्नेट के अराउंड आपको क्या डिस्पर्स करना है, क्या रखना है, छोटे छोटे आयरन के पीसेस. ओके, आफ्टर सम टाइम you will notice a difference that these iron pieces will align themselves in according to a different specific pattern. जो ये आपने आयरन फाइलिंग्स, जो आयरन फाइलिंग्स, आयरन पीसेस जो मैग्नेट के अराउंड आपने डिस्पर्स किए, this will align themselves in a specific pattern, and that pattern is this. You will see that iron pieces align themselves in this pattern. Okay, if I make this two lines, it is like, you can see the pattern and the lines of magnetic field. What are magnetic field lines? It will be from like this. Do you understand? Okay. So what are these lines? These are the magnetic field lines. These are the lines which show the direction of magnetic field. Okay. So these are magnetic field lines. जब भी आप आयरन फाइलिंग्स को मैग्नेट के अराउंड स्पेस करोगे, so they will arrange themselves in this pattern. इस पैटर्न में वो सब अरेंज हो जाएंगे. Okay. So this is magnetic field lines which are showing the direction of magnetic field. And direction actually क्या होगी? Always remember that magnetic field lines start from north pole and end at south pole. Magnetic field lines north pole से start होगी, south pole पे end होगी. तो डायरेक्शन क्या होगी? नॉर्थ से स्टार्ट हो रही है तो ऐसे. Okay, do you understand? From north pole to south pole direction. Similarly, from north pole to south. Okay, this is the direction of magnetic field lines outside a bar magnet. But inside a bar magnet, the direction of magnetic field is opposite. How? You can see that magnetic field lines always start from north pole. लाइन्स हमेशा कहां से स्टार्ट होती है? इस पोल से स्टार्ट होती है, नॉर्थ पोल से स्टार्ट होती है, और एंड कहां होती है? साउथ पोल. राइट? सो इट मींस, so this is the pattern outside the bar magnet, but inside a bar magnet the direction is opposite, which means from south pole to north pole. Okay, from south pole to north pole, and you can understand the direction will be like this. So you can see in this figure that all the field lines are starting from north pole. इस पोल से स्टार्ट हो रही है, इधर भी, यहाँ भी और यहाँ भी. You can see direction is away from the north pole. The direction of magnetic field lines is away from the north pole. मतलब lines जो है ना magnetic field north pole से दूर जाएंगे. So you can see direction is away from the north pole, but it is towards the south pole. South pole के towards. ठीक है? It means magnetic field lines enter into south. So do you understand that magnetic field lines always get away from the north pole but enter to the south pole? That's why here magnetic field lines are entering the south pole and getting away from the north pole. Similarly here, away from the north pole into the south pole. Okay, that's why the direction of magnetic field is from north pole to south pole. But inside a magnet, you can see the direction is from south pole to north pole. ये जो magnetic field lines इधर से आ रही हैं, they will have a path like this. So from south pole to north pole. Okay. So this is the pattern for magnetic field lines around a bar magnet. If you have a doubt, you can ask. Okay. So you must make this in your rough notebook. आपकी जो नोटबुक है उसमें साथ साथ आपको बनाना होगा ये. अभी आपके पास नोटबुक होनी चाहिए और अभी आपको ये ड्रॉ करना है. ठीक है, कैसे हम मैग्नेटिक फील्ड लाइंस को ड्रॉ करेंगे. So these magnetic field lines, you can see there are some properties of these lines. What are these lines? These show the direction. Second, that closer the magnetic field lines, stronger the magnetic field. Okay, जिस पॉइंट पर मैग्नेटिक फील्ड लाइंस पास है, क्लोजर है, इट मींस उस पॉइंट पे मैग्नेटिक फील्ड स्ट्रांग है. सो आप बताइए, एक पॉइंट ये है, एक पॉइंट ये है, किस पॉइंट पर मैग्नेटिक फील्ड ज्यादा होगा? ऑब्वियसली, क्योंकि एट दिस पॉइंट मैग्नेटिक फील्ड लाइंस आर वेरी क्लोज, बहुत पास है. इसका मतलब है यहाँ पर मैग्नेटिक फील्ड स्ट्रांग है, ज्यादा है, और उधर मैग्नेटिक फील्ड लाइंस दूर है. एक तो मैग्नेटिक फील्ड कम है, वीक है. सो क्लोजर द मैग्नेटिक फील्ड लाइंस, स्ट्रॉन्गर द मैग्नेटिक फील्ड. दिस इज द सेकंड प्रॉपर्टी. अनदर प्रॉपर्टी इज that you can see these magnetic field lines are away from each other and they are not intersecting each other. ऐसा कोई भी पॉइंट नहीं होगा जहां पर मैग्नेटिक फील्ड लाइंस एक दूसरे को क्या करें, इंटरसेक्ट करें. So magnetic field lines never intersect each other because if they intersect, there will be an intersection point. और उस intersection point पर एक point पर it will show two directions, but it is not possible. Okay. So at the point of intersection, if magnetic field lines would intersect, it would show that there is two directions at one point, which is not possible. Okay, so that's why magnetic field lines never intersect each other. Always remember that field lines never cut each other or intersect each other. कभी भी एक दूसरे को कट नहीं करेंगे, इंटरसेक्ट नहीं करेंगे, क्योंकि अगर कट कर लिया तो इंटरसेक्शन पॉइंट पर दो डायरेक्शन हो जाएंगे, so which is not possible. For example, these are two magnetic field lines. If they intersect at this point, it will show both direction. यहाँ पर भी and here. So दो डायरेक्शन पॉसिबल नहीं है, इसलिए मैग्नेटिक फील्ड लाइंस इंटरसेक्ट नहीं करती. So this is the magnetic field lines of a bar magnet. Bar magnet. Okay. So since a magnet has field lines, so an electric current also will have field lines, because current is also electric current, has also magnetic field. This is a current carrying wire. एक वायर है, सर्किट का एक पार्ट है, एक वायर है, in which current is flowing. Okay, so अभी आपने मैग्नेट के अराउंड फील्ड लाइंस को ड्रॉ किया. As you know that current carrying conductor also behaves like a magnet. So इसके अराउंड भी आपको फील्ड लाइंस को ड्रॉ करना होगा. It means इसके अराउंड भी आपको मैग्नेटिक फील्ड शो करना पड़ेगा कि मैग्नेटिक फील्ड कहाँ पर है. So how can you find out? बार मैग्नेट में तो आपने निकाल दिया नॉर्थ टू साउथ, right? But current carrying conductor में how do you find out? So to find the direction of magnetic field in a current carrying conductor, you need to learn a simple rule, which is right hand thumb rule. What is right hand thumb rule? Right hand means it will use something from right hand. Right hand thumb rule. So what you have to do, take your right hand. This is my right hand. Okay, you can see in figure. Apna right hand you have to lift, and this is your thumb. Okay, so what you have to do, you have to put thumb upwards and wrap your fingers like this. Okay. Imagine that there is a wire inside your thumb. Okay. आपके hand में एक wire है. You can imagine, and you can make position of your hand like this. Okay. So the thumb shows the direction of current. This is thumb and it is showing the direction of current, and the fingers are showing the direction of magnetic field. Okay. So imagine in this situation, the direction of current is from bottom to top, from down to up. Okay. So this is the direction of current, and magnetic field direction is this. You can see जो मेरी fingers हैं. If you can see my fingers, these are coming from the blackboard, right? If you can see, now this is right. The direction of current is upwards, and fingers are showing like in this manner. It means the lines are coming from the blackboard or your notebook. अगर आपके पास notebook है, तो उसमें आप देख सकते हैं कि fingers are showing away from the page. So direction of magnetic field will be like this. You can see this is current and this is magnetic field. So make the magnetic field lines. First we have to make circle. पहले आप circle बना लीजिए ऐसे. Okay. These show magnetic field and lines are from inwards to outwards. It means like this. You can understand. You have to practice this by yourself, by from your right hand thumb. Okay. So I am drawing this again. This is wire and this is magnetic field lines. The direction will be like this. ऐसे outwards है direction. बोर्ड से बाहर है, तो आपको lines भी बाहर लेकर आना. The direction will be like this. Okay. So this direction is clockwise or anti-clockwise. You can see the direction is anti-clockwise. Okay. So if current is flowing from down to up in a conductor, the direction of magnetic field will be anti-clockwise. Now if I change the direction of current from up to down, ऊपर से नीचे current flow कर रहा है वायर में, then draw the magnetic field lines. Magnetic field कहाँ पर होगा आपको show करना है. So first of all you have to draw circles. Now you can draw the direction of magnetic field. Take your right hand, you can see now the right hand thumb will show the direction. The thumb will be like this. It means that the direction of current is downwards. नीचे की तरफ है तो thumb भी आपका नीचे होगा like this. And when the field lines are into the board या फिर into your page, you can see direction is, if I place like this, it is into the page. Okay. So the direction will be this. You can do this by yourself. If current is flowing downwards, then it will be clockwise. So direction is of magnetic field is clockwise. If current is flowing from up to down. Understood? If you have any doubt, you can ask. You have to simply use right hand thumb rule to find out the direction of magnetic field around a straight current carrying wire. Okay, by practice you will understand. जो भी आपकी fingers की direction है वो magnetic field की direction है. अगर current ऊपर flow कर रहा है, you have to place like this. अगर current नीचे flow कर रहा है तो आपको ऐसे करना होगा, but आपको right hand ही लेना है. ठीक है, और fingers की direction जो है वो सेम डायरेक्शन आप अपने पेज पर ड्रॉ करो. ओके, दिस वाज राइट हैंड थंब रूल एंड द डायरेक्शन ऑफ मैग्नेटिक फील्ड टू फाइंड अराउंड अ करंट कैरिंग कंडक्टर. So this was a straight conductor. As you saw, this was a straight conductor. If this conductor was not straight, अगर ये कंडक्टर स्ट्रेट ना होकर, it would be राउंड लाइक दिस, क्योंकि वायर है, वायर को आप किसी भी शेप में चेंज कर सकते हो, आप उसका सर्कल बना सकते हो, रेक्टेंगल बना सकते हो. So this is a circular wire, circular copper wire, any metal wire. Okay. So current is flowing in this wire. You will draw all the diagrams, all the pictures in this class, okay, in your rough notebook. So this is a circular wire. This is a circular wire. To pass the current, we have to attach this to a battery. Battery तो आपको ड्रॉ करनी पड़ेगी करंट फ्लो कराने. This is a circular wire, okay, and direction of current will be from positive terminal to negative terminal. So in this wire, direction is clockwise, okay. एक circular wire है, you attach this wire to a battery, and it will, direction will be from positive to negative. So if you write down in your notebook, make this diagram in your notebook, and you will understand that direction is from positive to negative terminal. So now let's draw only the wire. सिर्फ wire को draw कीजिए. Draw a circular wire like this. The direction of current is clockwise. Clockwise current flow current. Now you have to draw the magnetic field lines around this circular wire. In right hand thumb rule, you studied that current direction is thumb. Current is straight, right? But here current is not straight. Current is circular. So how will you make this straight? You will take a segment of this wire. इस वायर का आप एक segment लोगे. Segment means any part. एक segment का part लोगे. This is a circular wire. You take a segment. You take this segment, okay? You can see that a small part of circular thing is straight. So ये part आपका straight है और थोड़ा सा ये वाला पार्ट इसका स्ट्रेट है. इस पार्ट में डायरेक्शन क्या होगी करंट की? सेम होगी जो ऐसे फ्लो कर रहे हैं क्लॉकवाइज. ऊपर ड्रॉ करते रहिए साथ साथ अपने नोटबुक में, ठीक है, और इसमें नीचे होगी. नाउ यू हैव गॉट two segments, two straight segments of this circular wire. Now you have got the straight current. Use the same right hand thumb rule. What was right hand thumb rule? Put your right hand. This is show the direction of current. It has two opposite direction. एक segment में ऊपर है direction, एक segment में नीचे है direction. One by one you will take. First you take the straight ऊपर की तरफ जो है. Okay. So you can see the direction of current is this. ऐसे है, ठीक है, from board towards you, from page towards you. So first you draw the circles. पहले आप circles draw करिए. दो circles आप draw कर लीजिए. इधर भी आप दो circles draw कर लीजिए, ठीक है. Now you will find the direction. Direction आपको कैसे मिलेगी? Same right hand thumb rule. From the fingers to the direction of magnetic field. So obviously the direction is this. Like this is anti-clockwise. You can see the direction is anti-clockwise. Okay. Now come to this side. You can see thumb shows direction. अब thumb आपको नीचे लेकर जाना है क्योंकि करंट भी नीचे है. Okay. And the fingers are showing the direction of magnetic field. Okay. So you can see the fingers are towards the board. मेरी fingers की डायरेक्शन जो है बोर्ड के अंदर है या फिर आपके पेज के अंदर है. So direction will be like this. You can see this is clockwise direction. Okay, so you have to basically use right hand thumb rule और जिस डायरेक्शन में फिंगर्स आ रहे हैं आपकी उसी डायरेक्शन में आपको रैप करना है. डायरेक्शन कैसे है, ऐसे और वही फिंगर्स भी ऐसे आ रही है, राइट. सो दिस इज द magnetic field lines. Okay, if you draw more circles it will be like this. Okay, you can draw more circles. Okay, as soon as you come in the middle, you can see that the middle line will appear as a straight line. ऐसा क्यों होगा? क्योंकि जो मिडल वाला सर्कल होगा वो इतना बड़ा होगा कि आपको सिर्फ जो भी इतना एरिया है उसमें से स्ट्रेट लाइन दिखाई देगी. Okay, so as you draw, as you move closer to the center of this coil, the circles become large. और large होते होते you see only this part, so this is a straight line. Okay, और इसमें डायरेक्शन क्या होगी? इसकी लाइन डायरेक्शन क्या है? इस पार्ट को देखिए आप, इस वाले पार्ट को देखिए. The direction is upwards, right? Upwards means into the board, into the page. So the direction will be same. Okay, जो डायरेक्शन आपको जिस तरफ ये पॉइंट आपको दिख रहा है उसी तरफ आपको मिडल लाइन भी उसी डायरेक्शन में आपको शो करना है. ओके, so I will draw this figure larger in size so that you can understand better. You must practice this on your own. अगर आप खुद से प्रैक्टिस नहीं करोगे तो आपको नहीं आएगा. This is circular wire. The current is flowing in anti-clockwise direction. Anti-clockwise, like this. Use the right hand thumb rule. Thumb upwards, magnetic field lines like this. So first draw circles. Five circles draw. ओके, दो ही काफी है. उस साइड भी आप सर्कल्स ड्रॉ करें. ओके, नाउ यूज द राइट हैंड थंब रूल. थंब अपवर्ड्स, मैग्नेटिक फील्ड लाइंस लाइक दिस. सो डायरेक्शन विल बी, आप एक डायरेक्शन को चेक कर लीजिए किस तरफ जा रही है, उसी तरफ आप सारे एरोज लगा सकते हैं. ठीक है, as you can see this direction is anti-clockwise. Now thumb downwards and direction is this. ऐसे ये डायरेक्शन कैसी है? क्लॉकवाइज है, तो क्लॉकवाइज बना दीजिए. सेम इसमें भी क्लॉकवाइज. ओके, नाउ आप बीच में एक स्ट्रेट लाइन ड्रॉ करोगे. स्ट्रेट नहीं होती है, सर्कल का ही पार्ट होता है. एक सर्कल आप ड्रॉ कर सकते हैं, क्रिएट स्पेस. Okay, so these are the magnetic field lines around a straight, sorry not straight, this is circular, around a circular wire. Wire कौन सा है इसमें? Wire is this one. ये वाला जो है आपका wire है, which I am marking from green. This is the wire. This is the wire and other circles are the magnetic field lines. Okay. So one more thing you have to understand, this circular wire and this field lines are in different planes. Okay, अगर circular wire ऐसे इस plane में रखा हुआ है, so magnetic field lines क्या है? इस plane में. Okay. These planes are perpendicular to each other. Okay, this line is not actually from up to from down to up. This line is actually into the board. Okay, ये लाइन ऐसे नहीं है एक्चुअली, दिस लाइन इज इनटू द होल। सिंस दिस इज अ 2D सरफेस, तो आप 2D सरफेस में ही देख सकते हो। सो दैट्स हाउ यू कैन ड्रॉ मैग्नेटिक फील्ड लाइंस अराउंड द circular wire. Okay. Now, if I ask you an important question, if I ask you that tell me which pole is north pole and which pole is south pole. Imagine this is a bar magnet. Okay, आपको पता है एक pole north होता है, एक pole south होता है. But if you have a circular wire, okay, अगर आपके पास कोई circular wire है, then in that case, what will be the north pole and south pole? For example, imagine this is a circular wire. Okay, poles ना होंगे इसके, एक जो फेस आपकी तरफ है वो एक पोल होगा, जो फेस दूसरी तरफ है that will be different. For example, this is a circular wire. जो फेस आपकी तरफ है that is imagine north pole, और जो फेस दूसरी तरफ है जो आपको नहीं दिखाई दे रहा that is south pole. Okay, so how will you find out the direction of north and south pole? कौन सा फेस north pole है, कौन सा फेस साउथ पोल? उसके लिए आप क्या करोगे? बार मैग्नेट को ध्यान कीजिए, बार मैग्नेट में आपने देखा था कि मैग्नेटिक फील्ड लाइंस ऑलवेज स्टार्ट फ्रॉम नॉर्थ पोल एंड एंड एट साउथ पोल। ठीक है, फील्ड लाइंस गेट अवे फ्रॉम द नॉर्थ पोल एंड टुवर्ड्स द साउथ पोल। इन योर फेस, इन दिस फेस, जो फेस आपकी तरफ है उस फेस में देखिए कि जो फील्ड लाइंस है इस फेस की तरफ जा रही है या इस फेस से बाहर आ रही है। यू कैन सी फील्ड लाइंस आर एंटरिंग इनटू दिस फेस, इस फेस में एंटर कर रहे हैं, राइट? इट मींस जिस फेस में एंटर होता है वो कौन सा पोल होता है? साउथ पोल होता है। सो इट मींस दैट द फेस टुवर्ड्स यू इज साउथ पोल एंड द अपोजिट फेस इज नॉर्थ पोल। अंडरस्टूड? आई रिपीट अगेन, जिस पोल में या जिस फेस में फील्ड लाइंस एंटर हो रही है, ओके, दैट फेस इज साउथ पोल। यू कैन अंडरस्टैंड फ्रॉम बार मैग्नेट कि जिस फेस पर, जिस पोल पर एंटर हुई वो कौन सा पोल है? साउथ पोल, और जिस पोल से लाइंस बाहर निकली है दैट इज नॉर्थ पोल। सो इस फेस पर देखिए, इसमें क्या होंगे? फेस होंगे, एक इधर वाला फेस, एक पीछे वाला फेस। ठीक है, सो इस फेस में क्या हो रही है? लाइंस एंटर कर रही है, राइट? सो दिस फेस इज साउथ पोल। फेस मींस ये वाला फेस, और इसके अपोजिट जो फेस है दैट इज नॉर्थ। ओके, अंडरस्टूड? फॉर एग्जांपल, दिस इज अ 2D thing. So this is one face and that is two face. It has two faces, one face and second face. Okay, ऐसे imagine this is a circle. This is a circular wire. Okay, this is a circular wire. This face is south pole and opposite face is, this face is north pole. Okay, so that's why this face is south pole and opposite face is north pole, and field lines are into the wire, into the face of the wire, like this. This shows the direction. ये जो लाइन है बीच में, ये लाइन ऐसे नहीं है, ये लाइन ऐसे है। फॉर एग्जांपल, दिस लाइन इज नॉट लाइक दिस लाइन इज लाइक इनटू द प्लेन, प्लेन के अंदर। ओके, सो दैट्स हाउ वी ड्रॉ द, I will present a video, 3D video to explain this. So I hope you have understood how you draw the field lines around the circular loop. So we are studying magnetic effects of current. So you have studied magnetic field lines around the bar magnet, around a straight wire, and around a circular wire. Three things you have understood. Now the last topic for today is what you have studied: circular wire. This circular wire हो गया. But if there are many circular wires like this, if you have a coil of wires, you can understand this is a coil of wire. It has many turns. एक वायर को आपने बहुत बार ऐसे कोई कर लिया, so it will form a coil with many turns. Okay, so this is a coil of turns, and this might be of copper wire, aluminum wire, any wire. That wire should be insulated. Insulated means copper wire के around जो है any insulated material wrap होना चाहिए. So such kind of wire or coil wire is known as solenoid. What is a solenoid? Solenoid. Solenoid is a coil. Solenoid is a coil of many turns. Many turns of insulated copper wire. इंसुलेटेड मीन्स अगर आप उस वायर को टच करेंगे तो आपको करंट नहीं लगेगा, क्योंकि उस वायर के अराउंड कैसा मटेरियल है, रबर या प्लास्टिक, इंसुलेटेड मटेरियल. इंसुलेटेड कॉपर वायर, insulated copper wire. Solenoid is a coil of many turns of insulated copper wires connected to a battery. Okay, so how can you draw a solenoid? You can simply draw the solenoid by like this. This is a solenoid with many turns. To pass the current, we must connect this to a battery. Okay, so this is a solenoid. This is positive terminal, this is negative terminal, as you can see. I will draw this again. Solenoid. Okay, this is positive, this is negative. Direction of current will be clockwise, positive to negative. ये जो poles है इसमें भी करंट ऐसे फ्लो करेगा, ऐसे वायर आ रहा है फिर ऐसे आ रहा है. You can see, imagine current कैसे फ्लो करेगा, like this. Okay, so that's how current flows in this. Now, as you know that every current carrying conductor has magnetic field. ये भी current carrying का conductor है, coil है. So इसके अराउंड भी have to draw magnetic field lines. इसका भी magnetic field होगा, उस magnetic field को शो करने के लिए हमें lines draw करनी पड़ेगी. This seems complex, but this is very simple. जैसा कि सेम आपने बार मैग्नेट में ड्रॉ किया था. बार मैग्नेट में आपने जैसे ड्रॉ किया था, नॉर्थ पोल, साउथ पोल, नॉर्थ टू साउथ, नॉर्थ टू साउथ. ओके, entering to south pole and moving away from north. That's how we draw the magnetic field lines around the bar magnet. Same आपको draw करना है, but for that you have to find out कि solenoid में कौन सा पोल नॉर्थ है और कौन सा पोल साउथ है. जैसे कि बार मैग्नेट में आपको पता होता है ये पोल नॉर्थ है, ये पोल साउथ है. तो नॉर्थ टू साउथ जो डायरेक्शन होगी लाइंस की, ओके, नॉर्थ से अवे होगी एंड साउथ से तरफ होगी. इधर आपको कंफ्यूजन नहीं होना चाहिए. नॉर्थ से अवे जाएंगी, हमेशा दूर जाएंगी लाइंस और साउथ की तरफ जाएंगी. सो इनसाइड जो है साउथ पोल. बट इसमें कौन सा नॉर्थ पोल है और कौन सा साउथ पोल है, हाउ विल यू फाइंड आउट? How will you find out that which one pole is south and which pole is north in this solenoid? To find out that, there is a simple rule. You must remember that rule, which is that if current is flowing in clockwise direction in solenoid, अगर किसी solenoid में clockwise direction में flow कर रहा है, तो जो left hand side है, left hand side कौन सी है? ये वाली left hand side है. ये left side होगा south pole, okay, और right side होगा north. अंडरस्टूड? बट आई एम ट्राइंग टू से आपको देखना है करंट की डायरेक्शन क्या है, क्लॉकवाइज है या एंटी क्लॉकवाइज. अगर क्लॉकवाइज डायरेक्शन है सोलेनोइड में, देन लेफ्ट साइड विल बी साउथ पोल, ओके, एंड द राइट साइड विल बी नॉर्थ पोल. और जब आपको साउथ नॉर्थ का पता चल गया है, देन यू कैन इजीली ड्रॉ the magnetic field lines around the solenoid. राइट जैसा कि आपने मैग्नेट में ड्रॉ किया था उसी तरीके से आप उधर भी ड्रॉ कर सकते हैं ओके सो हाउ विल यू ड्रॉ दिस इज clockwise direction so left side will be south and right side will be north so magnetic field lines from north pole to south from north pole to south first you draw simply these structures okay you can remove this battery or make this so direction will be you can see north to south and inside it will be like this okay so it will be away from the north and into the south okay so that's how you can draw the magnetic field lines around the solenoid you simply have to find out the poles and the same rule which you follow north to south you can draw and inside it will be south to north okay so that's how you can draw magnetic field lines solenoid if I change the direction of current in solenoid in this solenoid अगर मैंने करंट की डायरेक्शन को चेंज किया पहले solenoid बनाइए ओके दिस इज solenoid और इसमें मैंने करंट की टर्मिनल्स चेंज कर दी नेगेटिव हियर पॉजिटिव दिस इज नेगेटिव पॉजिटिव नाउ डायरेक्शन विल बी एंटी क्लॉकवाइज डायरेक्शन सो एंटी क्लॉकवाइज में क्या होगा क्लॉकवाइज में था लेफ्ट हैंड साउथ पोल लेकिन एंटी क्लॉकवाइज में लेफ्ट साइड कौन सा पोल होगा नॉर्थ दिस इज नॉर्थ पोल एंड दिस इज साउथ आपको सोलेनॉइड में शो करना है तो सोलेनॉइड में लीजिए नॉर्थ पोल होगा ये वाला और साउथ पोल होगा ये बिकॉज करंट इज फ्लोइंग इन एंटी क्लॉकवाइज डायरेक्शन नाउ सिमिलरली इन लाइक बार मैग्नेट ड्रॉ द मैग्नेटिक फील्ड लाइंस फ्रॉम नॉर्थ टू साउथ ओके फ्रॉम नॉर्थ टू साउथ एंड हियर like this same like bar direction will be north to south into the south away from the north into the south हमेशा लाइंस कहां एंटर करती है साउथ में into the south away from the north and so inside the solenoid direction will be south to so that's how you can draw the magnetic field lines around the solenoid. Okay, I hope you have understood. So write down your assignment. What is your assignment for today? You have to draw. If you have any doubt, you can ask. You can study from notes or NCERT book. You have to practice this. So assignment for today is first is in all that you have to draw the diagrams you have to draw magnetic field lines draw magnetic field lines draw magnetic field lines around first is very simple bar magnet second is straight wire okay third is circular wire and fourth is solenoid and you know the solenoid is a coil of circular wires in all these cases 4 cases you have to draw the magnetic field lines Okay, you can take any direction of current, स्ट्रेट वायर में डाउन टू अप ले सकते हो, अप टू डाउन ले सकते हो, लेकिन उसके अकॉर्डिंग ही आपको मैग्नेटिक फील्ड लाइंस ड्रॉ करनी है, ठीक है। यू कैन ड्रॉ बोथ केसेस, आप दोनों केसेस भी ड्रॉ कर सकते हो, क्लॉकवाइज, एंटी क्लॉकवाइज, डाउन टू अप टू डाउन, एनी केसेस you have to practice this more and more so that you can understand. Okay, so this class is over. Now you can take a break and prepare for next class.